All right, so before I get into the specifics of the solicitation, I want to provide some background on the facility itself. The ATRC facility is a low-power reactor which is located in the ATR complex at Idaho National Laboratory. The ATRC is a small pool-type reactor, and it's located in a sectioned-off portion of the ATR canal. This reactor, as well as the parent ATRC, were designed and constructed in the early 1960s. ATRC has a typical operating power of 600 watts or less with a maximum allowable power level of only 5 kilowatts. So it is a very low power reactor. And as I mentioned before, this is a pool-type reactor, so it is cooled by natural convection, moderated by water, and it also has a beryllium reflector. The operation of the reactor is controlled from the ATRC reactor console, and that is located at ground level right next to excuse me, the canal itself, and I'll have a picture of that in a little bit. So why does ATRC exist? Why do we have it? The ATRC core is a low-power replica of the larger ATR design, and as you can see on this slide in the bottom right-hand corner, it features a fairly unique serpentine core fuel design, and this design allows the ATR to maintain different power level and flux levels across the core in order to accommodate different experimenter needs. So the mission of ATRC is to obtain accurate and timely data on nuclear characteristics of the ATR core. Characteristics such as rod worths, excess reactivity, neutron flux distributions, rod worths, fuel loading requirements, and most importantly, it's used to study the effects of the insertion and removal of experiments from the ATR core. Nearly all new experiments that want to go into ATR have to first be tested in ATRC to verify their effects on the core. And fairly recently, ATRC has also been used for standalone NSUF experiments. This graph here, I just kind of want to give you a sense of the usage of ATRC. Since 2010, we've really seen a dramatic increase in the average runs per year. Historically, 2010 and before, we were averaging around 10 or 11 runs per year, and we're now up to over 60. The increase in runs is a result of increased work at ATR as well as the standalone NSUF experiments, but this increased usage has really been taxing on the antiquated control system, which brings me to why we're here. The purpose of this solicitation, which I believe will be listed as NEET-5, is for the detailed design of a modern control system for ATRC. A modern control system will help us ensure the continued reliability and availability of this asset. So I realize this is probably a semi-unique from the other work skips you've been hearing about, as we're a little more infrastructure-based as opposed to traditional R&D. On this slide here is the image I was talking about. This is an image of ATRC. You can see in the bottom, that's the reactor in the pool. There's a bridge going over the canal. And then in the background is the original console, which is still, unfortunately, in use today. So the vast majority of the ATRC control system is original 1960s or at best 1970s vintage equipment, and it's well beyond its expected useful life. And as a result of this, spare parts availability and technical support for most of the INC equipment is virtually non-existent. And this has made continual operation and maintenance extremely difficult. Our current projections are for ATRC to operate to at least 2030 and most likely beyond. So the modernization of this infrastructure is necessary to maximize the facility's reliability and efficiency. All right, so what are we actually asking for? The goal of this modernization scheme is based on providing a new, reliable INC system design that can operate the ATRC for 15 or 20 years into the future. This work scope will include the design changes necessary to make the reactor shutdown system compliant with current standards and requirements, but also limits the application of digital processor technology to non-safety functions. All of the safety class functions will need to be continued to be performed through analog INC components. Additionally, we'll also consider proposals for two approaches. One would be a complete system overhaul in one shot, and we would also consider the option of a phased implementation where we would replace, one component or module at a time, eventually leading to a totally new system. And this probably should go without saying, but all applicants will need to be able to meet all applicable access and quality assurance requirements. ATRC is a hazard category 2 nuclear facility. All right, so the detailed design effort would need to include the following systems, which I have listed here. They will include the reactor shutdown system, which includes several subsystems such as the neutron level subsystem, the log n period subsystem, manual scram and scram logic, the log count rate meter system, the non-reactor shutdown scram system, which is the seismic switch subsystem. We have the rod control system, the digital reactivity measurement system, and the annunciator system with indicator lights. So that's all I prepared to present to you. Obviously, I'm sure any potential applicants will want some more specific detail on ATRC, such as functional operational requirements, things like that. And we'll be happy to provide those by request. This slide has my contact info. Once again, I'm Jason Toki, as well as our technical lead, Craig Jackson at INL. So I am happy to take any questions that you may have.
Jason will take questions over the next few minutes. If you have a question, please type it into the question box on your GoToMeeting screen, and we will relay those messages to Jason. Why is this a NEET category rather than a normal procurement?
Yes, so the benefit, and if I step on anyone's toes, someone can jump in. The benefit we saw to NEET was it opens this up to universities, industry, as well as national labs, which is a broader base than we can normally get to.
This work scope seems more engineering in nature. Are there any components that are R&D in nature?
My honest answer is no, and that's a correct observation. This is more of a design effort than a R&D effort. And I may even go a little farther and say that we're not necessarily looking for a novel control system. We want something that's pretty tried and true and can get us through the next 2 decades.